guys, it's Gabby here, and welcome to my growth and decay factor video. Okay, so if you've already watched my exponential or my geometric explicit equations video, then you know that I've referenced this video and you've come here to watch it. If you haven't, that's okay. You can watch this video and then go and watch my explicit, my geometric explicit equations or my exponential explicit equations. I think I call it exponential in that one. So whether or not you're here because you've watched it or because you're going to watch it, it's a good video to watch. So our growth and decay factor. So it's used in exponential or geometric, as you guys call it, but it's called exponential more commonly, so I'm going to call it exponential. But they're the same thing. So our exponential or geometric explicit equations. So our exponential equation, which is labeled, thank you, is y equals a times b to the x. So what does this all mean? Well, we're going to break it down really fast. So a is our starting value, which is our 0. So say you start off with $100 in your bank account and your interest is 7%. So your starting value would be $100 because that's what you started out with. Your b would be your multiplier, which would be either your growth or your decay factor, which we're going to talk about in a second. And your x would be your time, was your exponent. Now x will always be time because time is independent and x is independent. If you've watched all my videos, I say that a ton, and that's because it's pretty much always true. X will always be time if time is in the problem, which it most likely is. Okay, so whether a value is growing, increasing, or decaying, decreasing, is going to be whether or not you're going to have a growth factor or a decay factor. So for our growth factor, you're going to add 1 to your percentage. But wait, I've missed a step here. What have I missed? Well, you've got your percentage here. So this is going to be either your growth factor or your decay factor. So, but this is just a percentage. I don't see any growth or decay with it. What do? Well, it's all in the context. So say I'm saying Sally's car is depreciating value 25% each year. And that would mean it would be a decay, like depreciating, decaying, decreasing. Those are all decay words. Growing would be like interest or increasing or adding or accumulating. Those are all like growth words. And you'll be able to spot those as you do more problems like this. So for this one, we're just going to say, we don't know yet. So we're going to say it's either growth or decay. So it's fine either way. So it's 25%, and we're going to do it in growth and decay. So what you first have to do is we can't do anything with this percentage. We need it into a decimal. So you always just move it to the left, and then you have your decimal, 0.25. So if it's growing, so if we know it's a growth factor, if it's accumulating or if it's interest and it's growing, then we're going to add 1 because this represents the 100% that you already have that you're adding to. So it's going to be 125% of what we originally had. So it's going to add to it. And if it's decaying, you're going to go 1 minus 0.25, which will give you 0.75. Because this one, you're taking away 25% of it. But you aren't going to write y equals a times 0.75 to the x, because that would, 0.25 to the x, because that would be you only have 25% of what you had left. But we're getting rid of 25%, so we still have 75%, which is what you're going to multiply by. You're going to multiply by what is going to be left. So for this one, you're going to be multiplying by more because it's going to be you're gaining, but if this one, you're going to be multiplying by what is left. So that's how you have to think of growth and decay. And I'll be right back with some examples. Okay guys, I'm back with my growth and decay examples. I have 2. Okay, so my first example. I own a bank. Lisa deposits $100, and the interest accumulating is 25% a year. So what is her account at the end of the first year? So what is in her account at the end of the first year? Okay, so that's kind of a big thing. So let's break that word problem down. And I always like to underline what's important, because the rest of it is just fluff. And sometimes they add in extra information to try to trick you. So okay, so we know Lisa deposits $100.